Yes, thank you. It is 3 p.m. and from our side, from POLARIXPartner, a warm welcome to everybody. I'm really happy to meet you here in our virtual meeting room for our first webinar with our new partnership with IoTco, which we want to present you today, where we can go really in depth for Industry 4.0, industrial artificial intelligence, and here today for zero downtime, zero defect, which means preventive maintenance in a nutshell, to capture how we can do it nowadays. I'm working in consultancy for 15 years around, starting in this field with very rudimentary way of working with Excel sheets, collecting data, and even this could bring the machines to a very high value of low downtimes. But now we have complete other opportunities, other options to get really far beyond this. And my colleague Hassan will give an impulse speech to it. And after this 10 minutes of impulse, Moab Ali from IoTco will continue in depth. And after approximately 40 minutes of discussion, we will have additional 20 minutes for altogether discussion, and hopefully afterwards we have a breakout with you to discuss in depth and help you with your longings. Thank you and enjoy our meeting.
Okay. Welcome, ladies and gentlemen. My name is Hassan Al-Bulumi, principal at POLARIXPartner. So I have an electronics background, almost 20 years of experience in a wide variety of roles and functions. Before my career in consulting, I was in the automotive and the industrial machine industry for 14 years, where I held various leadership positions in engineering, program management, and operations, both in Europe and Asia. So I specialize in digitization and value management, topic which is closely related to the planning and execution of cost reduction initiatives in the technology landscape. So I would like now to share with you the experience we have gained at POLARIXPartner in product launch and manufacturing of various industries, and look forward to an interesting exchange with you guys. I strongly assume that there are some participants who do not know POLARIXPartner. So in the next slide, I will spend some time in order to explain who we are and what kind of consultancy services we offer.
And Hassan, would love to see your video. You want to turn it on?
I can continue like this, that's fine.
Okay.
So next slide, Mo. So in the following, I will explain the POLARIXPartner consulting portfolio to you, based on the well-known constellation of the Big Dipper with the polar star that you see there above. Our company name actually is derived from the polar star. As you can see, we pursue a very holistic consulting approach that covers various phases of the product life cycle from the left to the right bottom. So we start at the top left with market and competition. We support here the customer in the interfaces between product management, product planning, and engineering, making sure that the customer and the customer requirements are translated in a good and cost-effective product. So integrating customer requests into product development is not always easy, as you know, especially when ambitious cost and quality targets are to be met. And then especially when you are operating in an environment which is very competitive. So what is needed for this are methods, tools, and the expertise to take into account the requirements of the customers. At the same time, keep an eye on the technical feasibility and last but not least, and very important, the opportunities on the market with regards to a good balance between costs and features. So we apply here a wide variety of tools and methods such as quality function deployment, functional analysis, or requirements management optimization on products, but also on manufacturing process side. Specifically, we support our customers in the competition analysis in order to evaluate their own product in relation to the competition, with special focus on cost efficiency. With this, we are able to assess the opportunities for cost reduction or product value improvements at our customer side. The customers usually trust our strong benchmarking and cost analysis expertise. We have, by the way, our own benchmarking center, which I will talk about and show later in one of the following slides. So in the next phase of the next element of our consultancy portfolio is within the product development phase, which generally follows after the product planning. So we in this phase, we cover the product and innovation management, which means in the early phase of the product management, the project teams are typically faced with many challenges. It may be that the concept phase, in the concept phase, the project teams are not able to put a price tag on their engineering concept or on their process solutions. As a rule, we support our customers here with cost know-how in order to create cost transparency during product or process development. Oftentimes we have product cost targets which are not met. As a rule, POLARIXPartner then support their customers with a combination of value engineering methods and cost analysis to meet their targets. Another topic where we support also our customers is the so-called technology assessment. We have consultants with a lot of experience in mechanics as well as electronics and software. These support our customers in introduction of new technologies in their products, especially with regards to costs and manufacturability. The topics are diverse. In this field, we have power electronics, LiDARs, battery technology, electrification in the automotive, or in this case, Industry 4.0 in the manufacturing industry. Because we work in many sectors, we can often offer added value with transfer of experience also from sectors who are pioneers in corresponding technologies. So there are a lot of analogies between project build, even though we cross industry borders from one industry to another, and we take the good solutions from one industry to another and propose this also to our customers. Typical questions are, for example, how can cost-effective LiDAR or radar system for automotive be applied in construction machines or logistics systems? Or as an example, can we achieve cost savings by using proven standard components from one industry in another? These are so typical questions and challenges and tasks where we support our customers. As for the third point, purchasing and supply chain management, our team of consultants support customers in optimizing their purchasing cost and supply chain optimization. I've already stated out that POLARIXPartner has strong expertise in the field of cost analysis. This comes into play here. We, in the first step, carry out cost analysis on a component or system level. And this analysis, or as we call it, cost calculation, serves our customers to identify and leverage saving potentials, especially in the following negotiations with their supplier base. This is extremely important part of our portfolio in terms of substantially and improving the competitiveness of our customers. Product or process related, doesn't matter, we cover both. As part of these initiatives, we also support our customers with long-term complex projects, which means projects which are running for years. As an example, platform developments for hybrid transmissions or DNA sequences in medical technologies, or other projects on products out of the industries, automotive, medical, energy, machines, or aviation industry. Yeah, in order to understand costs, one also has to understand production and operations and manufacturing processes, of course. Otherwise, one will not be able to reflect the cost which is induced by this part of the product creation. In the next segment, production and operations management, we support our customers mainly in process optimization. In the past and in the future, we will strongly promote the topic Industry 4.0 AI with IoTco as a means for further manufacturing optimization and leveraging efficiency potentials. Mo will certainly tell us more about this in his upcoming slides. Last but not least, we are often asked by customers to conduct training courses in order to have a know-how transfer after the project execution with the customer. Even though it's a minor part of our business, it's, in my opinion, an important element to anchor applied tools and methods substantially in the company, so that to ensure that there is know-how transfer and there is a footprint in the organization after we have conducted projects with the customer. Okay, I think so much for the consulting portfolio, which is diverse, but in fact always resolves around cost management, cost optimization, technology, and value proposition. You see in this slide that we have substantial growth. The company was established in 2012, starting with 11 employees, and we are right now at 43 employees, going forward with more growth. And the structure of our consultants mainly reflects also our consulting philosophy, which is shown in the next slide. I think the most important aspect here out of the philosophy is that our philosophy is to bring together the competencies and experience of management consultancy with a track record of operational experience. In the previous slide, you saw already that the structure of our consultants is 14 years plus of industry experience before they joined POLARIXPartner. Customers very much appreciate the support of experienced consultants who are also familiar with the requirements and the concerns of their industry. And this means that the majority of our consultants are industry and product experts with many years, and they can also lead in-depth and expert discussions with the customer in terms of implementing ideas for optimization on a product or process level. So the strategy for growth in the key markets, as we want to grow in the US, but also in China, the philosophy remains the same: strong expertise in technology and operations, commitment to real added value for the customer, and a high return of invest. And of course, a value proposition which is offered by the new technologies in the different fields of industry: automotive, medical, energy, machines, and other industries. Okay, here you see a list of customers we are already working with on various projects, and literally hundreds of projects we have done for these customers. This reads like who is who of the European industry, with a focus on Germany, Austria, and Switzerland, but also in the other parts of Europe. And as I said and indicated, we want to grow also in US and Asia with customers which we already have in Europe, which have a business footprint in Asia and US, but also with American and typically Asian customers. Okay, our headquarters is based in Saarburg. a small city nearby the border to Luxembourg. So I announced or I indicated already that we have a benchmark center. We look at benchmarking as a strategic aspect to deliver added value to our customer. In this center, we can give the customer really deep insight to competitive concepts by doing tear down analysis and cost analysis on competitor products, and really compare them with the customer product and working out the market differentiators, but also the feature differentiators and the cost differentiators between the competition and customers' products. We also have an office in Munich, which is also based close to one of our customers in the automotive industry. Okay, then I would like to quickly jump into the main topic of today. As for the Industry 4.0, I would like to share this interesting survey with you. The survey was made by Bitkom and published by Statista. In this survey, by the way, more than 2/3 of the respondents see Industry 4.0 as means to increase profitability, which is self-evident. That means that they are not going to implement Industry 4.0 for the sake of 4.0. This can be only done with a meaningful return of invest, of course. However, you see in this survey that high investment and low return are one of the main constraints for applying and implementing this technology. In addition, the survey also mentions technical expertise, missing technical expertise, and increased project complexity as two of the main constraints. And the conclusion of all this is that with Industry 4.0 and AI in manufacturing landscape, we don't really have a problem on a, I would say, broad consensus on the importance of this technology, but rather than a significant implementation problem, given the constraints that are listed here. So the majority find it simply difficult to use this knowledge for their own businesses. In other words, it is difficult to realize a good business case. These are the main constraints. And this is where we would like to step in with IoTco, combining two skills. One is the deep insight and expertise in the manufacturing industry, with the deep insight and expertise in software and application of Industry 4.0 and AI applications. And there are success factors for this, for the project implementations. So what are these key success factors? We call this course Think Big and Start Small. So one of the key success factors is to bring together software, hardware, classical mechanical engineering, and manufacturing know-how in order to ensure the success of concrete projects in the manufacturing landscape. Software and AI skills are extremely important, but not everything. I would just give you an example is with the data streams, sensors we get from sensors from the machine. We can only learn algorithms if we know whether the measured values show that the machine is currently in a good or in a bad condition. That means that I need to know whether there is data showing that a production process is running good or that it needs to be improved. So in order to prepare measured values so that they can be used to train AI algorithm, experts with good experience in mechanical engineering are also required. That means, last but not least, that means that software, hardware, mechanical engineering, and manufacturing expertise belong together. And then, of course, the second item is, or element that we see here is the fast transition from feasibility study to implementation. Oftentimes, there is a certain planning to implement AI or Industry 4.0 application, but the transition time is very slow. and thus the expenditures on the project, and at the end of the day, the ROI is very bad. And the third is the flexible solution to handle technologies, market demands, or complex products. Flexible solutions, flexibility. Just to give you an example, we have been investigating an application in a charging farm for electrical vehicles, applying a predictive maintenance approach. And the issue there is that you have a very fragmented or very variety of supply base for these high power charging units. So if we apply a specialized solution for one type of charging unit, how can we apply this solution for other type of a charging unit? So to make sure that the solution is flexible is one of the key success factors. Okay, concept of fast and cost-effective connection to the industrial IoT is a very important one to keep the investment low. And then leveraging the advantage of digitization across design, manufacturing, and service to have, again, this holistic approach, that it's not only that if we apply or if we roll out or implement a project, that it's not solely applicable for manufacturing, but what we leverage the cost optimization opportunities throughout the whole product life cycle, including design of the product and including the manufacturing of the product. And last but not least, use open hardware and software standards to prevent dependence. So any particular or specific solution increase the cost and thus decrease the return of invest at the end of the day. Okay, one other aspect for successful implementation of Industry 4.0 applications is good, efficient, and effective project management. So that's why we propose, from a good project management point of view, some key aspects for success. First, of course, a clear scope definition and formulation of goals that the company wants to achieve with Industry 4.0. This can be simply translated in measurable KPIs. In example, improvement of OEE or cycle times, or manufacturing cost per piece, in example, or other KPIs that can be chosen. So for a clear scope definition. Secondly, of course, a roadmap and an efficient project management for implementation of profitable applications after the readiness check. So for this, we have developed a project launch process that is divided basically in 5 phases, which we are showing here in a very rough manner. Just to underline that we work very closely with the customer teams in through all these phases. So for the phase 1, we essentially scanning with the customer the manufacturing landscape for application that promise a high return of invest. This we typically do with the customer. In the next phase, we make selection of applications which are suitable and profitable for implementation. Then the phase 3, which includes the definition of the performance parameters for the corresponding applications. As I said earlier, with clear KPIs and clear performance characteristics, which the team wants to achieve with this Industry 4.0 application. In this area is very much comparable to an engineering specification process, in which it's precisely defined which performance requirements the application must meet at the end of the day when it's rolled out in order to fulfill the business case goals. Phase 4 includes the implementation of the specification in an AI platform solution. I think Mo will tell us more about this in the following slides, especially with regards to the platform solution versus proprietary solutions. And last but not least, the application is rolled out at the customer in phase 5 with following fine-tuning to achieve the desired performance. On average, such projects take 8 to 12 weeks, and we constantly support our customers from phase 1 and are close exchange with our customers from phase 1 until phase 5. And with this, I would like to hand over to Mo for more details, especially for the AI part and the Industry 4.0 part. Mo, it's your turn.
Thank you, Hassan, very much. And thank you all for your time. My name is Moab Ali, and I'm a managing partner at IoTco. I'm based out of Ohio, but we operate globally as a company, and we strategically partner with POLARIXPartner in Germany and the DACH region. I would say something we share very intimately with POLARIXPartner is the manufacturing industry. Both our DNAs is manufacturing. We come from manufacturing, we serve manufacturing, and we focus on similar industries, overlapping industries with Polaris. And we also focus on overlapping domains of experience. So I'm going to talk about technologies, not only for the smart factory, but also technologies that and analytics that can be implemented for smart product applications. Some of the areas with which we are partnering with Polaris are primarily around our predictive analytics solution. But in addition to that, the Industry 4.0 training, which we plan to do together with Polaris, and also an end-to-end transformation services from the connectivity to the visualization, representation, to the analytics. So these are some of the key areas, and I will focus today specifically on the predictive analytics and AI area and how we're partnering with Polaris in this domain. This is a quick zoom in to some of the services we provide. We are laser focused on implementing IoT and analytics and Industry 4.0 training in manufacturing. That is all we do. And that is one of the reasons why we strategically selected POLARIXPartner to partner with us in this area. We both share the vision of a zero downtime, zero defect operation. Whether you're running manufacturing plants or whether you have products that you're sensorizing in the field, analytics are implemented to mitigate uptime issues and to mitigate quality issues in the factory and on the parts. So if we take a deeper dive for the next few minutes, and again, if you have any questions during the presentation, just please write it in the chat window, and we will have at least 10 to 15 minutes at the end to answer your questions. So 3 things: the relation between Industry 4.0 and predictive analytics, some of the technologies that we have in place with which we can quickly partner, and as Hassan mentioned, accelerated implementation within about 8 to 12 weeks, and then some ideas and a call to action on how you can start your journey and some of the things we plan to do with Polaris in the next weeks. So IoT is not a new field. IoT has been around for decades, for many, many years, but it has mostly been implemented on safety critical industries, jet engines, aviation, power plants, and so on. But in the last years, there has been a huge push to bring IoT solutions, including cloud, including analytics, and so on, into the factory floor and into the products on the field. So you have the internal industrial scenario, and you have the external, which is the product scenario. And if you look at industrial IoT, those are the typical layers you have in a factory. Your enterprise resource planning like SAP, your manufacturing execution system in some cases, your data acquisition, and your asset layer. So Industry 4.0 as an initiative is all about the convergence of IT and OT, your information technology, your business systems, and your operational technology on your plant floor or on your products, your sensors, your PLCs, and so on and so forth. So when we look at an Industry 4.0 strategy, together with the Polaris team, we are always focused on 4 key elements of that strategy. And I will actually start from the right and go backwards. It's all about the business case. It's all about the return on investment from the strategy that you're putting in place, whether you're running smart factories or whether you have a smart product strategy. And then it boils down to the nuts and bolts of how this works. Do you have connectivity? What is the readiness? How do you capture the data? How do you use the data? And then bringing that data into an analytics solution or an analytics platform that allows you to make meaning of the data and to start providing additional value based on the data to your end users, like the people in the factory running the machines, and also to your end customers, the people that are using your products out in the field. And then lastly, the technology conversation happens, the infrastructure behind it, the scalability behind it. Also, the idea of creating a center of excellence within your organization, which is a competence center that's able to take these lessons learned and actually scale them yourself across your operation. So business case first, technology second. And if you look at smart connected factories, or if you look at smart connected products, it's all about understanding your digital thread. Your digital thread is not just about making parts. It's about designing the parts. It's about manufacturing the parts. And it's about servicing and maintaining and the aftermarket of the parts. So this is 2 examples from 2 areas of this digital thread. The first area is manufacturing. That's inside your factory. How can you improve metrics like overall equipment effectiveness? How can I use analytics to improve uptime? How can I link to my spare parts system so I can predictive and optimization of my spare parts? I can reduce overhead and use spare parts in a predictive way. How can I improve quality, but how can I also predict quality issues before they happen so I don't continue making parts and then maybe ship parts to a client that have quality issues? So overall process optimization. But on the other hand, if I look at a smart connected product approach, I'm going to show a case study, for example, with a large heavy industry company. They make tractors and trucks. How am I able to take analytics and do remote monitoring and diagnostics of this equipment? How can I enhance warranties? I'm offering warranties to my customer, and I need to be responsive in my feedback to the client base. So how can I improve the warranties and responsiveness to my customer by using analytics? And then closed loop design. How can I feed data back from the field to the designer of my vehicles in order to improve future generation of my design and immediately impact my whole digital thread, improve the design, improve manufacturing, and improve aftermarket services? So the first quick case study I want to show is around smart connected product. And the application here was actually done with a heavy industry manufacturer. And this is not inside their factory. This is actually on tractors, okay, out in the field. And the tractors are in the desert. It is very difficult to actually maintain those tractor systems. And data acquisition is actually very difficult. So on each one of those tractors is a data logging unit. And the data logger is collecting data that is allowing a satellite link to open in the evening. And the satellite link is able to send data from the critical areas of the tractor and allowing the spare parts system of Komatsu to actually replenish spare parts to this desert region prior to the failure of the tractor. So the goal here is a 0 downtime mining site. My mining operation needs to continue running without any disruption, and data is required and analytics is required to make that happen. So there is actually an intuitive approach by which the Komatsu maintenance organization for the tractors is able to immediately see the different mining fleets that they have, and they're able to immediately see that there are issues in specific mining trucks, and they're able to zoom in to understand the critical areas of that mining tractor. For example, in this case, I have an issue with my engine, and my engine requires maintenance. And here I can see the trend that is reached to a specific warning level on the tractor. And this requires a spare part that is related to the diesel engine, for example. So by using IoT and Industry 4.0 technologies, and by using the right approach to collect data and analyze the data, the Komatsu Center of Excellence was able to start providing remote monitoring and enhanced warranty services to their end user, which is the mining site operator, right? It could be a company that's running that site, and to actually support them with a zero downtime initiative to run their mining fleet. Another example is around Smart Factory. Within Smart Factory, you have metrics to run your operations. And those metrics actually have similarities to the smart product metrics. One of the metrics is OEE, but in addition to that, there are downtime metrics, there are spare part metrics, there are also maintenance and labor scheduling metrics. Everybody wants to improve their mean time to repair, right? I want to repair machines faster, and at the same time, I want to improve my mean time between failure or mean time between stoppages. So from a maintenance perspective, predictive maintenance perspective, impacting your MTTR and MTBF and enhancing spare parts and maintenance scheduling is critical to the operation, whether you're running the mining fleet or whether you're running machines inside your factory. So keeping this ROI in mind, a automotive OEM with which we have partnered had a factory that is uptime critical. They're making cars, okay? And the factory had about 500 different robots. A minute of downtime in this operation was almost exceeding $10,000. Of course, it's a high number because they're making cars, right, at a very fast cycle time. This number may be different in your operation, but regardless, whatever number you have, you can translate that number to an ROI for your business and implement predictive analytic solutions that make sense. So of course, the 500 robots are, they're sturdy machines, right? They're not going to fail all the time, but we have about 30 robot failures that typically occur within a year. And each robot failure is an unplanned downtime of at least 30 minutes, which is quite severe in the industry. So when we did the math and we only looked at the power of uptime and the improvement of detecting and predicting downtime before it happens, there was significant savings for this plant. Just notice the number here, though. There is a very low estimation of the prediction capability. We are not promising 90% predictions. Only 50% prediction was promised as part of the ROI justification, and we were able to actually meet and exceed this number here. So think what ROI makes sense for your business, and at the same time, similar to the Komatsu example, this automotive OEM had an intuitive approach to show the results of the analytics to the end user. In this case, the end user is the maintenance organization. And it's important to understand that, the maintenance organization, they are not PhDs and they are not data scientists, right? They are strong maintenance experience domain knowledge. So we should show them intuitive solutions that help them run their business in a better way. And we should not expect them to learn advanced analytics, for example. So design your solutions in a way that is important for the end user. It has to be end user centric. So looking at the health of the asset in an intuitive way, looking at thresholds, green is your baseline, yellow and red are the adaptive thresholds, degradation level and the failure level. The remaining useful life prediction should be intuitive. Receiving predictive alerts by text, by email, or also integrating to SAP PM, for example, or IBM Maximo, which is your maintenance system. In addition to looking at a diagnostic of what is the root cause of the failure, right? What is going to fail on the machine? In this case, a specific axis on the robot is going to fail, right? This might be a FANUC or a KUKA or an ABB robot. And you do not want to go and change all the bearings on all the 6 joints because it is time consuming and some of the bearings do not need replacement. So the early replacement of good spare parts is a hidden cost to the business, right? And it has to be reduced. So fix the right area of the machine at the right time using the right person and fix it before failure. So it's a mindset change from a reactive mode of doing operational maintenance to a predictive and prescriptive mode of doing maintenance. So hopefully this quickly gave you just two examples around a smart connected product application, like in a mining vehicle in the middle of a desert where uptime is critical, and also a robot in a smart connected factory application in a factory where uptime and spare parts are also critical, right? So a few minutes just to chat about what is the technology behind this and how can you adopt this in a quick manner. One key technology is we provide a technology. I'm not here to talk about the technology. I'm here to talk about the architecture behind it. So it is a three-step approach, right? You have a data lake. It is important to understand what data is required to make this happen. And if you don't have the data already, how can we capture that data, right? So we have a team to support creating and improving your data lake. So asset data, data from the PLCs, right? Data from the data loggers, sensors that might need to be added on the machine, in addition to additional parameters potentially around the worker data, quality data, spare part data, and so on. Once that data comes into an AI-based engine, which I'll explain, that data is transformed into intelligent predictive metrics about the machine itself, and in some cases in the factory, also about the part that is being produced on the machine, okay? So with predictive maintenance, we're focusing on the health of the asset, the remaining life prediction of the asset, when is it gonna fail, with an accuracy, of course, and the diagnostics, what is the root cause of the failure, and which part of the machine is gonna fail. With predictive quality, we're actually looking at the production part that you're actually producing and making a prediction if you're gonna be making a good part or if you're gonna be making a bad part before the part actually goes to the next step in your process or next step in your value stream. And then it becomes difficult and exponentially expensive to fix the part, right? So let's say you have a casting or a molding machine, and then you go to machining, and then you go to paint, and then you go to the customer. Well, if you catch it right at the source, you save the most money, right? But if you catch it in the next process, or if it goes to the customer, that is a priceless issue with warranties and recalls and things of that sort. So a zero downtime and a zero defect operation is about the right data and the right analytics driving the use case that makes sense and makes ROI for your business and for your end customer. And within manufacturing, as another example, I mean, there's a lot of applications here. So we as an organization, we created a library of templates, and those templates bring significant domain knowledge to the industry, okay? We are not in the business of coming in and bringing a team of data scientists and running a data science project for 6 to 12 months. We're in the business of bringing domain knowledge that has already been implemented in industry, proven in industry, and actually delivering value within about 8 to 12 weeks, as Hassan showed in his presentation. We believe Industry 4.0 is about domain knowledge combined with speed of execution, okay? Knowledge and speed deliver quick value for your business. And that's why we actually are partnering with POLARIXPartner to bring Industry 4.0 very quickly to the manufacturing and to the smart product space. So just think whatever application you're running in your business, right? What is critical for your business? Robots, CNC machines, casting and molding and welding processes, stamping presses, and also ancillary components like the Komatsu mining truck that I showed has pumps, it has motors, it has gearboxes, it also has engines, right, that fail, diesel engines. There's a tire. So there is an additional set of templates that are also available and can be applied in the smart product domain of experience. But if we look at manufacturing just for a quick minute, and we just pick one of the templates, right? So I'm gonna pick the CNC machine template and show you a quick case study. And before that, I wanna show you kind of the 6-step process that is implemented in that case study. So everything that we do has that 6-step process built into the template, okay? And that is the domain knowledge I'm referring to. It is about a data map, a specific parameter set that makes sense for the application. We do not want an over-engineered system. We don't want to collect 100 and 500 parameters and then kind of pray for an approach to do things. We know that if this is an engine or if this is a pump or if this is a motor, there are specific parameters that are required for this process. That's the domain knowledge. And then this is the analytics workflow from the signal to applying the machine learning and mathematics, basically, statistical math, to extract meaningful features and metrics, convert that into an intuitive user experience, similar to the screenshots that were shown, about machine health and prediction and diagnostics. At the end of the day, the user is not interested to know that there's a specific algorithm running behind the scenes, but they're actually interested in the end result. They're interested in trusting the health and prediction and diagnostic values make sense for them so they can act and they can make decisions accordingly. So very quick application, CNC machines. It's actually a very complex application because there's a lot of moving parts, right? If you look at a machine tool, it is not just a machine. It is a series of moving elements. It is a tool in the spindle. It is a linear axis and feed axis. It is a gib. It is a coolant system that is fluids running through the machine, right? So if I want to come up with a machine tool health index, MTHI, to do predictive maintenance, there is actually a series of intelligent templates that are operating together for each one of the critical subsystems of the machine tool. So now if I convert that into the actual data map, right? Let's say I have a spindle, vibration monitoring is used at the spindle level, in addition to data coming from the machine control, like the motor current and the spindle speed. And this information for each of the critical subsystems is then becoming part of that template, that workflow, the analytics workflow I showed, and can be intuitively shown to the maintenance organization immediately. What is the health of your spindle? When is the spindle going to fail? The remaining useful life failure of that spindle. And a very detailed diagnostic, actually. In this case, I'm not looking at a robot, I'm looking at a bearing, and I am capturing the harmonics of the bearing. So I can tell you that this bearing is going to fail at an 8,000 hertz harmonic, or an outer race failure, or an inner race failure. So if I'm looking at specific components of a tractor or a truck or a bearing in a spindle of a machine, it's actually the same idea, the same analytics, the same approach. The end user might be different, but the user experience should be the same. There's a lot of similarities. That's why the analytics can be quickly implemented in both a smart factory application and also a smart product application. So hope this started to give a picture, to the audience. And I want to give a conclusion of maybe 2 or 3 quick slides about what we've shown today. And the first one is, how do I win with AI? Okay. And our lessons learned from doing this for many years is, do not start here, okay? Do not start here. Do not start by thinking, hey, what algorithms do I need? I want to pick a provider. I want to add storage. I want to get data in my data lake. Do not start here. Actually start here. Look at your people and your process before looking at your technology. Understand if you have the right internal business case. Start from the bottom upwards. What's your business case and stakeholders? What's the team and people that can support this? Do you have the talent, or is training required? Do I have the right processes in place? There are fundamental processes that need to be in place in order for you to start adopting Industry 4.0 AI and predictive analytics. And then go into the technical design side of it, which is the data and the analytics and the technology stack. So that's a significant lessons learned from those who have implemented this. Large companies and small companies, Mittelstand companies, who have been able to do this by looking at their assessment and assessing their people and process, and then embarking on the journey, okay? And again, one of the reasons we partner with Polaris Partners is we focus on first working and assessing the people and the change management and the process side, and then going into the technology implementation. Very quickly, think big, start small, as Hassan mentioned initially, right? And prove value and scale fast. But how can you really do it? Long story short, we have a 3-step process: discover, design, deliver, okay? Keep it simple. There has to be an assessment, right? There has to be a technical workshop phase. there's a proof of value, which usually takes about 3 months, 90 days. And if you're not proving value within 90 days, you have to immediately make a change. There has to be a pivot. There's a people, process, or technology reason why the 90 days did not give you the ROI. And don't think by extending it is going to give you the ROI. Don't extend it for another 90 days. You have to have a lessons learned. You have to understand the reason, and you have to pivot and make changes to ensure that the proof of value is successful along the way. And then scale with an internal center of excellence. The templates I've shown today can be given to the end user. Like you can be empowered to own and roll out the templates yourself across your organization to take ownership and to reduce significantly the rollout cost. So before addressing some of your questions, my last slide here is around thinking big and starting small, okay? And also acting now, because this environment or this area has become extremely competitive. And to continue being competitive, having a zero downtime and a zero defect vision and having a strategy to start implementing these things allow those best of breed manufacturing folks to become extremely competitive in the industry. And the industry has become extremely competitive. And those analytics and domain knowledge can be used in both a factory setting and also a product setting. And the end user may be different, but the ROI and the business case is still the same. And we want to answer a few questions. I think we have a few questions in the Q&A. And before we do that, maybe Hassan, if you come back and just quickly talk about the roundtable approach that we want to do in the near future. You might be muted, Hassan.
Yeah, thank you, Mo, for the presentation. Yeah, I would like to pick up one of your last sentences. Act fast, think big, start small, and act fast. So besides showing the powerful capabilities of AI in the manufacturing area, but also on the product side, I think one of the main goals of this webinar is also a call for action. The goal in question here is how can manufacturing, medium-sized companies, what we call here in Germany, Deutscher Mittelstand or Deutscher Premium Mittelstand, be pioneers with these applications. The aim is to move from theoretical approaches to really practical machine learning and big data processes in order to really improve the competitiveness of the companies. So that's why we proposed in this call for action a roundtable with our customers. So the participants should be the Industry 4.0 adopters, which see room for profitable applications and applications for ROE or high ROE in the area of Industry 4.0 and AI. Here, I must add that we have in a way to make sure that in this roundtables there are no direct competitors, which means first in will participate in this roundtable. So then the format is discuss really Industry 4.0, AI, and all the complex topic that you presented, Mo, and how this can be translated in real applications in the manufacturing area and the product area. So the proposed schedule is quarterly for 90 minutes discussion with interested companies. And the next session would be in March 25 at 2 p.m. on a regular basis quarterly. So this is mainly the aim of this call for action, to really move from theoretical to practical, and from practical to identifying real applications for this powerful topic, and then implementing and rolling out in order to substantially improve the cost picture and thus the competitiveness of the companies. Mo.
Thank you so much, Hassan. And we really hope some of the folks who attend today's webinar could join us in this opportunity to share knowledge. And also we plan to bring industry speakers to share their experience as well. And if you're interested, please reach to Daniel and Hassan, and we're welcome to immediately involve you. But maybe a quick question, Hassan, and you can start and I can continue the answer. Sometimes it isn't always clear for leaders which Industry 4.0 initiative to adopt, right? There's a lot of things. There's AI, predictive, connectivity, augmented reality. I can list 10 to 20 things right now. POLARIXPartner and yourself, do you have any advice in finding the right Industry 4.0, fit and technology for a manufacturing company?
I think Daniel can tell us a lot of cases in his specialty, in his field, medical industry and pharma, where he has done a lot of projects in terms of improving manufacturing efficiency. So every industry where we have high fixed assets, high cost fixed assets and machines, which play a role, and we need zero downtime. This is the ideal state. I think is a ideal application field for this kind of technology, definitely. And I would not rule out that other processes also come into play here. And we don't have to forget it. You showed in Mo that it's not only applicable for processes, but also for a feature set in products. There was a good example with the Komatsu truck that you showed. So we don't have necessarily to restrict the capabilities of this technology to processes, but also to products if there is a real business case for that, of course.
And Hassan, just a quick add to what you said for the audience today. We also have an Industry 4.0 assessment approach that we do in partnership with Polaris. It depends on the initiative. It's somewhere between 1 to 3 days. And this Industry 4.0 assessment helps us understand your baseline and conduct a gap analysis, and then provide you Industry 4.0 roadmap recommendations. There's a lot of technologies out there, but again, we start with the ROI, and then we understand the connectivity, the analytics, where you are around the people, process, technology, and then we make the relevant recommendations to help you get started and move forward in a phased approach, actually. It is a journey, and a journey is about a phased approach in execution and keeping an ROI mindset.
Yeah, it would be, of course, interesting to hear from one of the participants here, if they would like to come forward, whether they already had some experience with AI applications in the manufacturing or the product field.
And we do have one last question. And it could be a concluding question. Maybe thinking towards the future, Hassan, any comment about how you see this evolving in the next 4 to 5 years?
It depends, of course, as presented in the very beginning, is there's no company which is going to do Industry 4.0 or AI applications for the sake of AI applications. So the strong KPI here is return of invest, and a meaningful business case is always required. So, and given what you showed for different projects and products and processes and what we see in the market, this is definitely an evolving and a growing topic in the industry, definitely. And we see it as our one of the key strategic growth parameters, and where we would like to step in, also in conjunction with you guys from IoTco.
And my last comment is around We talked about connected assets, right? We talked about connected products. One thing we didn't talk about today, which maybe we'll talk about in the roundtable, is actually around connected worker. So people, how can we connect people with intuitive HMIs, human machine interfaces, so they could see data, they can run their machine and process in a better way, or even augmented reality type of approaches. Nowadays with the current situation, it's difficult to travel, for example. So we had a client that sent where we sent them a glass, right? They wore an augmented reality glass. They looked at the machine, and we were able to guide them remotely to fix the machine, right? Without even have to incur travel costs and quarantines and all that. So I think it's important to have a strategy around the asset, the product, which we talked about today, but also a connected worker strategy, which I think will also be a conversation that we'd like to have during the roundtable.
Okay.
So I think with this, I want to thank POLARIXPartner very much for the opportunity to give this presentation. And Daniel, if you want to say a few closing words.
Yes, thanks a lot, Mo, for your in-depth speech of such an interesting way of improving preventative and predictive maintenance. So out of my experience, it is the most important thing to design the right process, to collect the data first, to know which data to collect. There was another question of a participant, how we are using historical data, for instance. So first of all, we need to know what kind of historical data we need to predict a failure. So if we know which data is really required, we can define the right sensor and connect in our complete system. And as you said, the interface, human machine, is very important to want to plan or to schedule the operators, to schedule the maintenance team online, and to do some repairs just direct from wherever you are. I mean, a smartphone you have for so many services, but not for the process industry, not for the manufacturing. And this is really 4.0, maybe even the next step beyond. So I'm very interesting for additional discussion and roundtables with you, how we can capture this interesting field and can make a real competitive advantage for our economy.
Thank you for the opportunity, Daniel, Hassan, and we'll share with you the recording and presentation. Thank you to the audience, and have a great day.
Yes,
thank you all.
Yeah.
Thank you. Bye-bye.
Bye-bye.
Bye.